In this video, I'm going to talk you through with this beautiful, beautiful chart, the advanced, and I'll mention the basic requirements as well and how they fit together. But I'm going to give you some sample code and answer, I'm sure you have lots of questions of what you actually have to do and what you don't have to do. This is a tremendous amount of work for a video that will be completely irrelevant in less than 8 weeks. Why am I doing this? I'm doing it so that every year, 6 years, when they go to do their coursework, actually makes no sense because they're going to be in college. I do it out of sympathy for those who read a brief and don't understand what to do and panic. I was that student. So I wish someone made videos for me when I was a babby 6th year, only this same height. So yeah, anyway, let's just start at the top of the chart and work our way down. Now, speaking of this chart, which I've just started talking about, you can't just take a screen grab from this YouTube and put it into your project. You got to do your own chart, right? I made this chart. Look, I colored it in with the fill tool. I didn't even go outside the lines. I don't think that's possible. But still, if you copy my chart and then submit it to me, and I'm correcting exams this year in the summer, and I see my own chart, I'm not going to be like, hey, I made that. That's cool. I'm going to be like, I'm reporting you to the final boss of the SEC, and he's got a mustache. I actually don't know who the boss of the SEC is, but, you know, he might have a mustache. Who knows? I'm going to start at the very top of the flowchart, and the first thing we're going to gather is the well-being, the features of well-being. So according to the brief, the way you can take this data in is manually, programmatically, systematically, hydromatically. I don't remember what the brief says. No, some of that was real. Manually, programmatic. Manually, just write it down on a piece of paper, like count up sheets. Programmatically, I guess you write a program to take the things. That's actually what I'm going to do. I'm going to write a Thonny program that says, how do you feel mentally? And then, how do you feel physically? How do you feel environmentally? How do you feel? Just pick 3. I give you some there in the flowchart, right? And where did I get them? Definitely not ChatGPT. I didn't know what features of well-being was. I was never taught well-being. You know, back in the 80s, do you know how we got through the day? Pessimism and bleakness, and we were allowed to be happy 3 times a week in moderation, only once our homework was done. There you go. There's some to choose from. Pick some. In the brief, they do give you some external sources. I've gone down through those. They're actually quite nice. You can get some data on people's various things. Like I'll show you a screenshot here below. There you go. That's what's in them. I'm going to just take them in manually myself with a Thonny program, because I'd be a little bit concerned if I started using external data and also have my embedded system, that I'm going to end up with 2 sort of disconnected projects. I'm not quite sure how to marry those together very well, so I'm not going to, because I'm going to make my report as easy as possible to do, and I would like my report to be about 1 project rather than 2 separate ones, if that sort of makes sense. I'm sure some people will do it really well, but I'm just going to make it easier for myself. So this code is super simple. It's just going to take in 3 variables and on a scale of 10. And then down here, it's going to average them. You'll notice that I've changed these to integers because input always by default is a string data type. So you need to change that to an integer. Because you can't get the average of words, right? That doesn't work. So once I've got my stuff here, it's going to get the average of these 3 and then round them to 2 decimal places. So let's say it was 4, 3, and 5. The average, I'm feeling like about a 4, you know? For the embedded system, you're going to use a microbit. Like 80% of people will use a microbit to send data over USB cable to their PC or laptop. And that's your embedded system there. You could use Raspberry Pi. Posh people from Cambridge are going to use Raspberry Pi, and they're going to do it all on the Raspberry Pi with no external laptop or anything like that. Very fancy. And then there's the 1% of people who are doing it doing this externally. No one else in their school is doing computer science, and they're using Arduino because their Swiss uncle used Arduino, and they've using it in C or something like that. There's always one. The only thing you're not allowed to use is a PC by itself. You must have a microbit connected to it for it to really to be this, like this is your embedded system here. You can think of it as anything you can hide in your bed is probably an embedded system if it's a computer. You can hide this under your blankets, this under your blankets. You can't get a desktop PC and hide it under a blanket. If you can't hide it in your bed, it's probably not embedded. That sort of makes sense. I mean, it doesn't make sense, but it's a good way of remembering it. As for what sensor to use, you could use literally any sensor you can connect it to well-being. Everything's connected to well-being these days, so light. It's too bright. My well-being is sore. Ow. Sound. This sound is giving me a migraine. Resistance sensor. You know what? Physically nothing, but Scientology will use an ohm meter, and what do they call it, like an e-meter, and it measures emotional states, or I don't know. And if they don't believe you, just sue them for religious persecution and just say you're a Scientologist. There you go. Even literally an ohm meter could be connected to this project as your sensor. So just pick one. Most people are just going to be using the internal sensors on the microbit. That's totally fine. I'm going to use one of the external ones just so I can fit it to an analog pin, because I want to tick off the analog part of the brief. Do you know what I mean? It does say that. Now look, you could get philosophical and argue what is or what isn't digital, but I'm just going to play it safe. What's that? That is the oldest letter in the alphabet. Even in Sumerian, it looks like a snake, because that's what noise it makes. It's a snake. It makes sense. It's like 1,000-year-old. I'm going off topic. You need to do both. That's a plural in English, right? Well, I say you need to. I don't know if you need to, but it says S, so why take a chance? Just maybe do 2 inputs or outputs digital and 2 inputs or outputs analog. So if you want to be safe, I'd have under inputs, I'd have an analog input on my microbit, like a sound sensor or a light sensor. And I'd also have some buttons for a menu. There you go, you've got 2. And you know, you could even argue, just say in the report, that when you're typing in your Thonny program, that's an input, it's digital input. And then for outputs, have something scrolling across the screen. Note in your report that if you're using a USB cable and sending serial out digitally of your microbit, that's a digital output, you know? So don't hide the fact that you have more than one input or more than one output. Like, make it easy. Just literally say that you did it so that they can just tick it off real quick. So here's the code for this. I'm not going to go into the block code in microbit on how to do this because it was in the last video. But let's just say you've got some stuff coming from your microbit. Actually, I never saved that code, so I'm going to have to very quickly just check what my device manager is here and figure out what's my COM port. It looks like maybe 9. It's either 3 or 9. Okay, so I just set this to 3. Remember, you can find this code. Just Google STJ handy code. You can find some little snippets. So we're going to use some of these common snippets of code to piece together a project. But I mean, you know, there's Stack Overflow and loads of different places to get code from. I'm going to just press go on this. Does 3 read anything? No. Let's try 9. There we go. It's trying to read stuff in there. Okay, grand. That's the light levels. Super. Right. So I always use my absolute basic test code here, which is under microbit sense, actually microbit serial, and it's the very first one. That's the one I was running there. Now I can kind of skip on to, I guess probably I'll just use this one. Read explained. Sure, why not? Okay. So when I copy code in, best way to do is grab it as raw. I'm going to pop back into Thonny here and just give this a go. Remembering to set my port to port 9. There's a lot of try and excepts here. I think I said this in the other video,
but this was only in here because I was leaving this on for about 12 hours for a real life project, and it kept crashing out when I got a none value. So I'm not going to put this in because I actually want to know if I get an error. I don't really need to stop it like this. Okay, so I'm just going to get rid of that. I can also get rid of this try as well. Try except. There we go. Super. Now it'll crash the program when it gets an error. I mean, I know that's might seem like a downside, but I need to know if there's an error. Otherwise, it'll just give me nothing. Great. So if I run this now, I should just get some nice numbers. Give it a moment there. 503. Yada, yada, yada. Okay, so that looks good so far. So now that I've got this working, I'm going to put this back into the code. Just before I put it in there, I'm just going to tidy it up because some things don't really apply. Like I'm not going to stop the program. Do I want it to a while true? Not necessarily, but look, I'm going to put the whole thing in there. Back into my project, my main file here. Okay, now again, I'm going to, you would not normally leave these here in these kind of snippets. You know, I mean, this is kind of like a bad idea. You really should have all your imports up the top of your program. I'm just going to leave them in here like this because I just think for you watching the video, it's easier for you to understand that this block requires this import. Okay, so if you're doing this, your project, you just put all your imports up the top again. So now I'm going to do the microbit part. So it's going to do this for a while. I don't want it to do it forever. I just want to do it like 10 values. So for x in range 10, just do this 10 times. And this could be it could be for whatever. Look, but I'm just gonna go x. Great. So then let's just see what we get. Oh, do you know what I'm going to do? When I do this and I get my output, the signal in, I might replace what I probably was in your, I suppose in your program, maybe just change signal into, you know, sound level, light level, whatever it is for you, like a better name for that. So remember, you can always just go find and replace, and it'll replace every instance of this. So I'm going to do this, and I'm going to get all of the signal ends and replace it with light level. Replace all. Right. I don't need a break. I'm just going to append this to a list. Oh, wait a second. I need a list. Better get a list. So I need a list of light value. So let's say light list is equal to a blanky list. So this right now here is just a blank list. Nothing, it's an empty list. I'm now going to append all of these light level values to my list. So light list dot append, apply some glue, stick at the end, put in my light level, just like that. Add it to the list. I'm going to take out this print every single time at some point, but let me just see. Let's see what we got, because it should build it up. This is a good time to stop and check the program works. So there's my average values, and then it's going to start reading light levels. Now it seems to be taking a little bit of longer there, so I must have a pause in there somewhere, do I? You know what I probably do? I probably have a pause in my microbit code. Yeah, so I should probably tell that to hurry up. You know what? For the sake of this video, I'm going to change this in future to just doing like 4 or 3 values, because I really should just get rid of the thing. Let me just change the value of some light here so I get different light by putting my finger on it. I'm just moving around the light sensor because it was getting very consistent readings, which is cool, but it's just going to be confusing. So it's got 10 values. There we go. Lovely. That's pretty much it. Now I can, at the very end, just print my list of light values is da 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 da, and just put in the light list. There's my light levels. So I now need to pick out from a bunch of values what my minimum, my average, and my highest value, let's just say that is. Okay, so I know I've got a light level, so I'm going to say like max light is equal to, well, I can just do max light list. Min light is equal to min light list. And have I got, I think I already had like the statistics.mean imported, right? So I don't need to do it again. Well, I feel like I'm almost tempted to put this in here for you just to show them I'm about to use statistics, but look, you can see it, it's there, right? So so I can now use mean. Great. So I can say average light, I'll say mean light is equal to mean light list. All right, and that is 3 values. Print. Whoops, I deleted the bit where I'm supposed to be changing that light level to an integer. I may have removed that line. Okay, so back up here, because it was a string and I was trying to get the average of 3 words. Well, that's going to be bad. Okay, int. It's now an integer. Do you know what? No, I'll make it float. So it's a decimal, right? There we go. Now if I run it again, it should work just fine. And there we go. So there's my list of values, and you can see I've got like a minimum, mean. Now the only thing is that looks ugly. So, you know, how could I get rid of that? Well, I suppose I could round it off, you know, if I wanted to 2 decimal places. So I'm just going to go round here, round, and before just put a comma to do it to 2 decimal places, just like that. Okay, there we go. So I've just put in the comment there, choose my 3 parameters. These are my 3 parameters, but I said you can choose whatever you want. Harmonic, average, standard deviation, go mad. Lovely. So there's my list, and I've got my 3 parameters there.
Validation. Validation is just saying that it's the right data type. The numbers that are coming in your program are actually numbers. Or if you're taking a string, it's letters like toast, you know. Or an alphanumeric, it's a letter or number. So the reason this is important is because when you're using sensors, quite often, especially with the freaking DHT11 humidity sensors, it will return to you not 0, but none. Nothing at all. None type. And that is different than 0. If you can imagine 0 Celsius is cold. It's freezing. It's what where water freezes. None is where you get your thermometer, you smash it with a hammer, get the broken glass and mercury, and throw it at somebody and say, there's your measurement. There is no measurement. What temperature is that? It's nothing. And that's what happens sometimes. And that will crash your program. Because when you say, what's the average of 2, 3, and crushed up glass and nothing, your Python is like, glass. So it doesn't know how to deal with a none type. So you can have something in your program that says, if data type is none data type, you know, skip over that or register to that, log that as an error, some kind of validation. And I'll just show you an example of that now.
So to check the type of the thing, I just put in type and the light level. Okay. And if I press go on that and I run it, I can take a few readings, and you see every time it says it's a float. And that would say if it's an integer, and if it was a none type, it would probably print a none. Okay, this is a okay light sensor. It tends to not give rubbish data, but those DHT ones, if anyone's using those temperature sensors, this is why validation is a really necessary step in embedded systems. If you leave this for a week and come back and figure that 3 days in it broke, you just wasted 4 days of your life. So this is going to be really easy to do because of the way I've laid out my program. all I have to do is just above this, right before I attach it to the list, I just say, hey, if this light level here, if the type of the light level is, what data type did we say? We said it was a float. And you can set this to integer if you want to check if yours is an integer. Then do this. There you go. So only add them to the list if they are a float. Like, just think of this as like a nightclub or something like that. And there's a guy outside going, if you're not a float, no. Okay. So if a none type goes down through here, it will never get appended to the list. It'll just be overwritten the next time the thing goes down through the loop, which is perfect. So there it is now a validation. Now, just make sure that when you're doing your code and you're reporting on it, you want to just say validation, put that comment in there so that there's very clear evidence that you've validated stuff, right? Don't hide your work.
For the processing step, we're going to use a little bit of a trick here. Instead of taking 3 sensors, because it says technically in the brief 3 parameters. Now, 3 parameters is not 3 sensors. It's 3 levers, 1, 2, 3, that affect an output. You think like A, B, C, X. So instead of taking in 3 sensors, or if I was using external data, taking in 3 columns of that data, I'm just going to record my sensor over maybe 10 to 15 seconds, take a whole bunch of readings in a Python list, and then go, okay, parameter 1 is the smallest one, parameter 2, the biggest one, and parameter 3 can be like the average, Because when it comes to looking at well-being, maybe seeing a very bright light, like very quickly, is what really affects you. Like the peak brightness is the most important thing. And that's what we're investigating here, is the effects of some kind of sensor value on your mood. And it's not necessarily the average or the first one you get. So they're valid parameters. So you just open up the Python statistics module, have a look down. You can pick any of those. Taking your sensor data, and so you can have like mean, mode, medium, harmonic mean. I don't know what that does. Google it, but it looks nice. Why not? Standard deviation, like how far away they are. All of these things can be returned to you very quickly with the Python statistics module as part of your processing before it goes towards your graph or your model. So that's what I'm doing. Instead of taking 3 sensors, I'm just taking 1 sensor reading for about 10 seconds, and then I'll just take 3 sort of statistics from that list, and I'll use those as my 3 parameters for my model. For storage, I'm going to store all these values onto a spreadsheet, also known as a comma-separated value file, a CSV file. It's like Excel or whatever, right? That's my big pasta pot where I put all the ingredients in. First 3 ingredients are my parameters. I had min, I had max, and I had average light level. And then my 4th column in that CSV is going to be my target variable. So that's the mood. Remember I had like average mood. I'll just say average mood, right? Rather than the different moods. That's what I want to predict. I want to predict what your average mood is going to be given different parameters for light levels. But for you, it could be sound levels or movement or whoever. It doesn't matter. So those first 3 are my independent variables. The way I remember this in science is I'm very independent. Look at me doing all the things. Boop, boop, boop. I'm moving levers up and down. And what is going to happen to my 4th? That's my target variable. That's the dependent variable. That's my mood. What's going to happen to my mood if I do this? And I set these 2 levers to max. So that's how this works. I'd call this in some of my programs just like A, B, C, X. My 3 variables predicting the 4th.
So to put my stuff into the CSV, what I'm going to do is just going to use some boilerplate code here. This is just a code snippet. You'll find this on Handy Code. The only difference here is when I was messing around with this before, I was just putting in the survey results. So you're going to change these to whatever is coming in from your sensor. So I'm just going to copy paste all this in here. The bottom bit there is just to read it back once I'm done with it. Right. This is using pandas. That's like a little module for reading spreadsheets and playing with data. I'm going to leave the CSV import in there. Again, you normally put that at the top. I'm going to leave it in. So yeah, you just change that in yours. The survey results is just the name of your file. A, it means append mode. W would be write mode. And, read mode, you're not going to be using here. We're going to be using pandas actually to read a thing, not the CSV module. So change it back to A, which is append mode. That there is just to shorten things. Like, for example, you see this loads in Python where they don't want to be writing that out every time, so they just shorten it to some variable name. You could call it X if you want. I'm going to call it CSV and like that's one that I made up. I always think it's a bit of a giveaway. You can tell if it's my code or someone else's code, because what they shorten things to is sometimes a bit silly. Like DF is a standard one for data frame for pandas. You'll find that all over the internet. But I think CSV, I think I made that up, and it looks very me. So sometimes it's a good way to spot, like if someone's copied your code, if you have that, especially novices, but they don't realize that that's like, that could be anything. So they put in something very personable in there. Anyway, so I'm just going to replace these values with whatever sensor you're using. So for me, it was my max light, it was my min light, and my mean, my average light values. The average mood has not changed much, so that's actually the same. I don't think I called it. Yeah, that's the same variable. Cool. So I have a print statement to report back what we added, just to check it was all working. A space, and then close your file here. You do need to close that file, otherwise the spreadsheet will not work. It'll be blank. Then we import the pandas module, and we read back the data frame object is what it's called, like a spreadsheet looking thing. When you run it the very first time, you will find you might get problems. And this is very important for your project in general. When you submit a project for your leaving cert, do not submit it with blank spreadsheets. Always run it a few times, get the bugs out, make sure there's some data in your spreadsheets, because when you go to run your program, it will give an error if there's no data in it. How could it get the average of nothing plus nothing divided by nothing, So always run your program a few times before zipping it and sending it off to the SEC at the deadline. So let me just run through this, and you'll see where it says empty data frame. That's my problem, and it doesn't really look great. Like, it doesn't look like a CSV, but it's fine. All I do is I run it a few times. So like 2 or 3 times is fine, and you'll see it start to come together. There you go. And now you can see like row 0, row 1. And you'll notice something weird about the row before 0. The thing that should look like column headings is also a row of data. That's not right. Okay. So what we're going to do is we're going to open up that CSV file, and we're just going to change the headings manually. You'll only have to do this once. And I said, as long as you don't empty out your data completely, you won't ever have to do this again. So the best way to do it is just to go to open. Yeah, you can open it in Excel, but like just use Thonny. It's neater, it's quicker. Just make sure you go to all files, otherwise it will be invisible, you won't see it. There you go, all files, your CSV, and you can see the very first row there is data. So just change that, don't put spaces in it, watch out. Change that to the names of your columns. Now you can just use plain English here, but I'm going to just keep it consistent, just so I don't have 2 different versions of the column name. Pandas can use that column name to like get the average of that column and all that kind of stuff. So this is really important, and it does matter. So make sure you've got the right names for your columns there. All right, there you go. So now I'm going to save that. Actually, might just close it off as well, because if you leave it open, it's opened by 2 different things. So I'll just make sure it's saved and then close it. All right, now press run on your program, and you should find this time it'll have really nice looking column headings. Look at that. And now it looks like a proper grown-up spreadsheet of data. All right, so there you go. That is your data storage step all done.
For your predictive model, you're going to have a situation when you've got an A, B, and C, so 3, predicting a fourth variable, which is what we call X, right? So in my project example, it was min, max, and average light levels predicting your mood. Now, that's 4 variables, 3 predicting a fourth. If you think in school, you've got a 2D graph, you've got a 3D graph with 3 dimensions, but we're talking 4. Yeah, if you're having trouble visualizing 4 dimensions, stop. You probably can't, okay? Unless you have a crazy dream and you've had a lot of cheese the night before, unless you're a higher dimensional alien species, you can't experience 4 spatial dimensions. I watched his video, I don't understand it at all. You're not supposed to understand 4 dimensions. You can't. It's physically impossible. One student complained to me when I was talking about dark energy, and I was like, no one understands it. They were like, I thought it was a terrible lesson. I didn't understand dark energy by the end of it at all. It's like, that's a freaking mystery of the universe. You're not supposed to understand it. Don't criticize me. You can't experience 4 dimensions. So just relax. You can't 5, 6, 3. You live in 3 dimensions. That's okay. Look, height, width, depth, 3 dimensions. Yeah, you can't visualize this. It's not my fault. It's whoever let you into this universe. Ask them. So, good news is, maths can do as many dimensions as it likes, and you can just press go, and it'll give you the answer to your prediction. Okay, this is just a fact of the universe, and luckily for us, maths is not limited to our 3 dimensions, because yes, there's height, width, and depth, but when you're trying to predict something, let's say like risk of type 2 diabetes, there might be a whole load of factors. It might be your height, your age, your weight, and blood sugar, and blah, blah, blah. A whole load of them, right? Predicting another one. And that's just a multi-dimensional problem. Each column in that CSV can be called a dimensional problem, but it's not a dimension in how you think as like a spatial, in outer, like space around you dimension. This is getting very technical for Leaving Cert project, but like, that's kind of cool though, isn't it? That like maths could just like shoot off beyond our dimensions and just doesn't give a shirt that we live in a 3-dimensional universe. Yeah, maths, you go.
To complete advanced requirements 1, 2, and 3, I'm going to just do this all in one code session because the video's getting long and you got places to be and projects to finish. So I'm going to say, go to handy code, ALT3 simulations, ignore these 2. They're nice, but they're X versus Y, and that's not what we need here. For this project, we've got 3 values predicting a fourth. So any one of this one, or this one. I'm giving you choices here. I'm not telling you an answer. These are 3 ways I found to do it. This is probably the most detailed one because this very first one here, I've got some what if questions also in there. All right. So I'll run through these. Firstly, showing you how to do the actual model thing. How do you make the prediction? You'll need to install the sklearn package. When you do it, you'll see sklearn and it'll say depreciated. Use scikit-learn instead. Do you know what you should do? Use scikit-learn instead. Just go up here and put it in there. Search it, install it, enjoy it. There you go. All right. You may need this to actually get. Install one or both of those. I don't know. You know the deal, right? You keep pressing run, and when it says no whatever installed, you go up to this, find whatever, and install it. Right. This is the crux of it here, right? It's gonna have a lot of stuff here like blah 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 blah. But then when it gets down to it, it comes down to just 2 lines which you actually need to understand. Predicted value, your X, is going to be a function, and that just takes A, B, and C, your columns, right? So the first 3 columns of your spreadsheet, you put that stuff in there, and it comes out with the 4th one. Isn't that nice? And then the line after that is probably going to be your predicted value is, and just that is the same as that there. Look, huh? Let's see this in action. So this chunk of code here is kind of straight out of the docs for sklearn. you'll find it on any of that, wherever the website, the documentation for this is, right? So it will be no different. They'll just have different, I suppose, column headings here, and what they're predicting will be different. They might have 4 instead of whatever. Look, let's just go through it. You import stuff. That'll be the same for you. This will be the name of your data set, not my data set. If yours is called your data set, I'll be suspicious. Your X data, that is your independent variables. In this case, because the exam says, you need 3 parameters, whatever it is, I would just put in 3, as we've been doing so far. And then you're predicting your mood score. Okay. And then for me, that was, I think, I just simplified that to an average mood score. So in scientific terms, they would call this the independent variables. I'm very independent. Look at me changing things. And this is your dependent variable, the thing you are predicting, right? Then it does some stuff. It splits it up. You'll notice that in other ones, this changes from linear to poly or whatever you want to do. There's different versions of this. We're assuming everything is magically linear, which it probably isn't, but whatever's. It trains and fits and does some stuff in the back end, right? Like I said, it's like importing the sleep module. You don't need to work out how it works out what 1 millisecond is, or you just go sleep 1 and it works and you're okay with that. You don't have to explain every module, because if you did so, then you'd be like, well, where did that come from? And then you end up explaining 1s and 0s in machine code. So, so I've just added a thing here saying the thing is done. The oven is making bingy noises. Look, done. And then I wanted to know, actually, does this work? So I noticed that the example they gave came with this mean squared error being printed, and that just tells you, hey, is that value actually a good fit for your trend line? Do you know what I mean? Is there really a relationship between the light and your mood? Well, I would hope so, given that I completely fabricated this data, because I wanted it to look kind of like a straight line. Yours might not, and that's okay. There's no marks lost for there not being a trend. You're just reporting on a potential method to investigate this. You don't have to find a positive or negative correlation. You just have to have something that works to see if there was a relationship, would this pick it up? So this line here just prints how good those little dots fit the trend line here. So the best way of explaining it is if I just open this up here and show you on a graph, you see the way they're kind of like fitting. So if these all went in a perfectly straight line along this red line, then the mean squared value would be 1. It's not, but well, let's just run and see what we get here. Okay. So I press go. I wait a moment because it's doing some heavy lifting, Now, mean squared error was 14. How good is this model? Good model accuracy. I've just put in an if else. You don't necessarily need to do this. You don't have to include this in your model, but aren't you curious to see if this is actually a good value? Because otherwise it says, I predict 71. And you're like, how sure are you? And it says 71. So at least now I can say that this is a good fit for the data. So far what we've been import, we have a bunch of code. The model is done training. All right. Then it checks how good it was. Now that it's all ready to go, we put something into it to test it. All right. And this is what this does. It's starting to put predictions into this model. All right. So we've trained the model up here. We've got a trend line, and now we're putting in our predictions to see when we put stuff in, what do we get out? And here's this line I referred to earlier. Do you recognize it? Where it's got my predicted mood and my inputs are hours, sun, and peak. And, where did I get those values from? Well, I just said hours is, hey, user, enter in an integer for the number of hours. This is a float, you see? This is a float. I did that because in the requirements it says you need more than one data type. Or is it 2 different data types? It's a number anyway. So there you go. There's two different, there's an integer and a float. And it makes a prediction. So let me do that. Now, you don't have to let the user put stuff in here, but I'm going to get closer to a what if question here. So enter the number of sunlight hours. Well, let's say 5 hours. Enter the amount of the sunlight intensity. I don't know, 400. And the peak, it went up as high as 600, let's say. Now it does some stuff. I'm just going to put these aside for a moment because I'll explain that's for our what if in a moment. So I put in some stuff and the predicted mood score was 71. Did I say 71 earlier? That's so strange. How did I predict that? Maybe I'm GPT. So the code we just looked at was this. 3 inputs and it ran a prediction and then printed the prediction. Right? Not so bad. All right. In fact, this is even too convoluted. I don't need to do that. I can just hard code them in for a what if question. Right? Here I got the user to input them using input. Here I just hard coded them. 3, 100, 200. And the what if question I asked was real simple. What if all 3 were kind of low? Mood little sun is the new variable name I gave it. I mean, I could keep using predicted mood, but you see, I'm going to do a few ones here. I'm going to do little, and then I'm going to do loads, and then I'm going to say a comparison. What's the difference? You know? So to do a comparison, of course, I need to give them different names because otherwise I'd be comparing A to A, and I'd be like, which A are you talking about? So that's what I'm going to do here. What if question 1? What would your mood be if you've just got low values for all those 3 variables? Perfectly good thing to ask. So set this to 3 or 2 or some low value. I mean, given there's 24 hours in a day, 2 is not a lot. 100. I just pick numbers that are low. All right. I ran a prediction, and I put this in here. This B, and C is there. Peak, and then you print X, A, B, C. There's your X, right? And let's see what I got. The low sun score mood is 12. Oh, diabolical mood. You'd be wrecked with 12. I don't know what that actually means for mood, but it sounds low. So what if question 2? What happens if your sunlight, your 15 hours of sunshine, I don't know what kind of place in the world you are. What would happen if I just changed that to like 25 hours in a day? There's some maybe validation code you should have to, well, anyway, yeah, I won't for now. So my what if question 2, the answer I get is 117 is a lot bigger than 12. So when I increase these numbers, which was my second what if question. Now, technically I've already ticked the box, right? Because I've asked my 2 what if questions, and that's what the brief said. And I've called this one loads of sun. This was A, this was B, this was C, and there's my prediction X. And I print X again here, and that's what I got. All right? Then what if question 3, I was just curious, which is more important? Like, could you predict, for example, if you get a sudden blast of sunshine when someone opens the blinds, is that actually more significant than the average sunshine over the course of a few hours? You know, maybe you need that like wake up flash to cheer you up, remind you that the sun exists. Well, we're going to test it out, and here's how we're doing it, and here's how you can do it too. So I'm not just giving the answer, I'm giving you lots of different ways of approaching what if questions, things you could ask. So first I worked out a baseline. So I put in average type, numbers in there. It doesn't matter, pick one. Anything could work here because you're getting something to compare the next two to, right? I'm going to call this baseline. I print it. So what if question 3, I'm going to keep A the same. So in both cases, I'm going to go sunlight hours 6, sunlight hours 6, and my other comparison, all of these are 6. I'm keeping A the same. Then I'm going to double B in the first one and double C in the second one. Double B being the average and double C being the peak. So let's see what happens. So with these baseline values, my mood was 54. And when I double the average sunlight, so I just doubled this went from 300 to 600. Wow, that went up to quite a lot. That's a very happy mood. So the average seems to matter quite a lot. What would, if I didn't double the average and said double the peak? I got a sudden flash of sunlight. What would that be like? Well, 51, which is actually less than 54. So maybe that would just upset me that someone shone the sun in my eyes and then it was gone all of a sudden. You know, I don't know. But look, that's what the model says. I don't know what we've learned from our made up number spreadsheet. But isn't it kind of cool though that like if you did record, and maybe you should, if you record your values over a few days and put it into a model like this, you really can make a scientific prediction and a discovery, and you might find out something really, really cool. You might find something awesome in the data. So that's what we're gonna leave it at with the predictions. That was our 3 questions. Now we have to get on to AR3, which is reporting on this stuff. You could do things like this, where you have a graph or whatever, and highlight your prediction on. But the easiest way to do this is you just show the what if predictions. They were numbers like 115, 51. Why not just show those to the user on a bar chart with a comparison? And that's what I've done here, right? For what if question, there's 1 and 2 on the same chart. So there's a little bit of sun, loads of sun. I'm so glad I gave them different variable names now, and they weren't like A versus A. All right. So if I close this, look, it's another outcome. So this is my AR3 box ticked twice. Mood if you double it, mood if you double the peak. I really probably should have put a third one here saying what the average is in the middle, my baseline, but there you go. All right. So, and I've put down here, it's the average that improves the most. How did I work that out? Well, okay, aside from putting in my charts there, this is the code. I mean, I'm not going to go massively into how to do a chart in Python. Okay, maybe I should, because it is a how-to video. Look, very quickly, you import matplotlib. These are the names of the things in your axis. You can type in your granny's name there. It won't break your graph. It'll just have a weird label. This does matter. This needs to have like a list in it. I say list for a bar chart. No, right? No, not a list for a bar chart. I would think it's scatter plot. For a bar chart, it just needs to have one number, like 15, and this, and that will do a bar chart. But my numbers are the outcomes from my simulations. Yeah. Then you put this names versus values on a bar chart. You label it. The X is the horizontal axis. The Y is the vertical, the uppy downy one. And you give it a chart title, something relevant, or just call it Fred. It doesn't matter, And then don't forget plot.show. There's other bits of code here. You can render it and save it as a file, a picture, but like you don't necessarily have to. Okay. And this was what I wanted to talk about. This is some extra like printed feedback on my stuff. I'll just call this printed feedback. Printer feedback. Weird. So you can see it just says whichever one wins, because I didn't know which was going to win. So if the average one, I said if it's the average that improves most. If the peak, I'd say the peak, and it turned out to be the average, right? Because this one is bigger than this one, so it went down that route. All right, and that could be another way of ticking and reporting on AR3. What other things could I could show you for AR1, 2, 3, and that kind of thing? Well, this one here, if I just put in some values, this one returns a nice graph of my data. Now, of course, it can't graph something in 4 dimensions because your brain would explode and you would lose grip in reality. So it's nice to you, and it just gives you slices. It goes mood versus hours of direct sunlight, and then it goes mood versus average sunlight, and then it goes mood versus peak sunlight. Again, you don't have to do that. If you want to just stick to the bar charts, you can, right? This is a pretty cool 3D graph. If I just put some values in here as well. There you go. Oh, actually, I forgot to add one of the values there. I only asked me for the second one, but it doesn't matter. But look, isn't that nice? And in this as well, because I just want to make sure I ticked AR3, which is reporting, like showing my prediction graphically. Yeah, it's showing my graph, which is showing my model, but my prediction is this red dot over here. Okay, that's my prediction from the output there, right? Pretty cool. What else? Oh, so the 3D graph is pretty cool, but there's not one way of doing a graph. There's a gazillion different types of graphs you could do. Any visualization is totally fine as long as you show a prediction. While I was correcting last year, I found a few students using this from my school. It was really cool. It's like a cyberpunk skin that works with Matplot library. Isn't that savage? So you can if you want. It didn't work with the 3D, unfortunately. But one of my 6th year students did get it to rotate pretty cool, and added some music. So all that was linear regression, which is just an XY graph, except in more dimensions. Now, what about like a quadratic graph or a cubic graph? Because sometimes things are not linear. In fact, they're almost never linear, right? So you could also use this polynomial one. See, there's kind of like a, well, gosh, it's not a very good example, but there is a bit of a curve to this. And my prediction is down here. Look, see, it's not totally straight. It's a bit kind of wavy. So how do you do that? Well, let me tell you the wonders of this one tiny thing that changed. You see, before it said linear, and now it says polynomial. Madness. And there's 3 degrees, so let's make that's cubic. Let's do 2 quadratic, so that's like x squared x cubed, right? So let's say 3 hours, 300, 400. There we go. And it's trying to do a curve there, and you can see it's highlighting the predicted outcome, and it's going to give me slices 1, 2, and 3 different slices. There you go, and that's a polyfit one, right? And technically you could even use a neural network. I don't know why you would. Maybe because you just want to be cool, and all the cool kids use neural networks. But look, you can if you want to. I don't think it's a very good fit for the data, but like, let's give it a go. You press go, and now TensorFlow loves to give you a bunch of red text here. It also likes to take a while. This can make your computer cry. My computer is fast enough, so it's going to go through this pretty quickly. And okay, even with 230 epochs, it was still 44, which is not great. You can change if you want to give it more time to figure out stuff. You can set this to like 400, and it might make it better, but also that might just overfit it. Overfitting is when you just join the dots in a graph. So like if I was like, oh, look how good my fit is. Yeah. And I just start like zigzagging. You're like, oh, it's a perfect trend. You're like, no, that's not a trend. That's joining the dots. So let's see. 29. Average model accuracy. Yeah, I don't know. Questionable. You could set this to a gazillion. It might just take a long time. Anyway, there you go. So that, it's no different in that what do I do? I put in A, I put in B, I put in C, and this is X. Oh, I call them unfortunate names, I suppose. Anyway, this is your prediction, right? So you get your data set, and you just do it the same as the other ones. I thought using a neural network was hard. Nah, don't worry about it. It's grand, sure. Google and TensorFlow, basically Keras and TensorFlow are a very nice plastic cover on top of a big load of maths. So they've made it like absolutely easy to use. Is that okay? So, I mean, you'll understand this bit. You might not understand some of this going down here. But the thing you want to actually change is probably this to go up and down. And look, You can spend all day learning about how to make neural networks work best. But to be honest, in this case, you're probably better off just sticking with a multiple linear regression and then showing a bar chart at the end. Is that all right? So now, why am I doing a multiple linear? It's because in the brief it said a model that involves, that makes a prediction using 3 parameters, and that is 3 parameters, A, B, C. So a predictive model wouldn't. I know you could do a bar chart with going in, but that's not a bar chart. Doesn't really not making a prediction. Bar chart reports on something. It reported on 2 of our predicted numbers at the end there when we did a bar chart, but it wasn't making a prediction. So anyway, there is a school of thought that would say that you could just make up a very fluffy, psychologically silly, love minus happiness equals exercise times light level, and put it into your report. And to be honest, no, I don't think anyone can really mark you down for doing that. And maybe some people will do that, and it'll be cool, to have silly made up pop psychology formulas. But I suppose, you might get totally lost that. At least I know this works. Okay, I may have fudged the data because I wanted to get this video to you before the project is over. Where if I gathered it over 7 to 8 weeks, it wouldn't be very much use to you.
And that is it. That is the whole project from start to finish. So yeah, good luck with it. I mean, also good luck with me for the next 5 hours of editing. I haven't even written any code yet. I mean, you've probably seen code before now. It's just been me and a green screen. Just some general advice about your project. The number one mistake I suppose people make is that they don't realize that most of the marks go for the report. So a good project will not save you from a bad report, right? So don't be doing fancy things like fingerprint scanners and involving satellites in your project. Just get it done quickly, and then put all your time into the report. That's what it makes sense. It's okay if it's there have been meh projects, it's not meh, but just vanilla boring projects that have gotten a H1, and there have been amazing wow, I audibly said wow when there was no one in the house, and they've gotten H3. I was like, that's a pity. They didn't, for example, talk about some of the problems they had in detail. They just left out sections. Probably because they didn't consider a problem. Maybe they were so into coding that they just didn't consider errors and puzzles to be a problem. They were just like, well, that's just part of coding. I was just coding. So best of luck with your project, whatever you choose to do, whatever sensor. You'd be grand. You'd be grand. You get it done in a day or so if you just knuckle down. Big liter of Pepsi and an Easter egg. Just lock yourself in a room for a weekend. Don't talk to anybody. Get it done. Don't be dragging it out. Get it done quickly and get on to studying for exams.